So I made some changes, and yet even though there is the X and Y are in the sprite class, is there an X and a Y in the Mario class? Yes, because Mario extends sprite. Everything Mario does, or everything sprite does, Mario does too. Everything Mario does, sprite does not necessarily do. Only the Mario does it. Catch that? Okay. Any questions on inheritance? Yes?
Are there limits to how a class can extend a sprite class, per se, after the sprite class is declared as such?
Are there limits to how a class can extend other classes?
Yeah.
I'm not aware of any right now, so I'm just going to say no, unless you have a more specific example. Okay, some languages provide a special thing you can write. I can't remember what it is. It might be final. And if you say it's final, then that basically means nothing can inherit from me. I'm not quite sure why that would be useful or why you would ever want to do that, but some languages do that. And maybe Java does too. Should we try it? Let's find out. Oops, I ran it and I meant to build it. Illegal combination of modifiers, abstract and final. That makes sense. Aha. So apparently Java does support final classes. I guess if you declare a class final, nothing can inherit from it. So there are ways to create limitations. I see no value in that. I say never use it. You can't have abstract and final. Why? Yeah, that makes sense. The whole point of abstract is to extend it so your child classes can do what you say they must do. This is kind of your grandfather imposing rules on your life. And the whole point of final is to say you can't have any children. There's probably some metaphor there. And yeah, they're not compatible. Okay, so we made a little progress there. Now here's something kind of cool we can do. We have inside of our model an array list of tube. Wouldn't it be kind of cool if we change that to an array list of sprite? Now, if you think about that for a minute, do you see how that gives us new powers? Because we can stick Goombas in that same list, we can stick tubes in that same list, we can stick Mario in that same list if we want to, and we can stick fireballs and everything else that we want to in that list because they're all sprites. And now the model gets really, really simple. All the model has to do is tell all the sprites, update yourself, update yourself, update yourself, update yourself, and all the sprites go and update themselves in different ways, and the game as a whole just works. Kind of cool, isn't it? Okay, well this is a technique called polymorphism. Let's define that. Poly means many, morph means change, ism, religion? I don't know what that is. Polymorphism basically means you've got a whole bunch of objects, and even though you're going to call the same method, like update, for example, that method is going to morph to do the right thing for the corresponding object. Thus it's it basically means a bunch of stuff can all behave like one kind of thing. You've got a big list of sprites, they're all the same thing, they're all sprites, and yet you can say to each sprite, update yourself, update yourself, update yourself, and they're all going to go do it their own way. So there are many things are going to morph to do the correct version of update when you call them. Do you get what polymorphism is? Yeah.
Like, if you use the sprite class to do that, how do you know the sprite will update the correct values without mixing them? Because Mario and tubes and Goombas all have that similar code.
That's true. So how do you know that the correct method will be called? In fact, I guess let me just describe how it works. Polymorphism, the condition of occurring in several different forms. Apparently it's a word in biology and genetics, biochemistry, computing. A feature of a programming language that allows routines to use variables of different types at different times. That's a pretty weak sauce definition. Okay, well, for your knowledge, let me describe how polymorphism works. Do you remember when I said that every class actually knows about, there's an object that goes along with every class? I call it the class object. So let's suppose these are instances of Mario. And I draw it red because Mario wears red. I'm trying to create a theme there. And let's suppose that this dark red thing up here is the class object for Mario. And every Mario object has a reference to its class object. Now, in fact, even before I point that out, I should probably point something else out. In Java, there is a class called object. Have you ever heard of that? Let's look at that. Java object class. It's a funny name for a class because a class is not the same thing as an object. So to call a class object is kind of weird. But here's the deal. Object is the base class of all classes. If it were the family tree, this would be Adam and Eve, right? Object is the root. Everything extends object at some level. So even if I make a sprite class, let's go back to my code here, model. I have the sprite class. I could, if I wanted to, say extends object. And in fact, in Java, it's impossible not to extend object. Here's why. Because if you don't say extends anything, if you don't add an extends method or extends statement after you declare a class, the compiler says, oh, you forgot to extend something. So I'll just extend object for you. And thus, every class you make extends something. And by default, it extends object unless you tell it to extend something else. Thus, object is kind of the root of all classes. In this case, Goomba extends sprite, and sprite, I didn't specify extends anything, so the compiler adds extends object, and the result is there's this hierarchy. Basically, this is Goomba, which extends sprite, which extends object. And everything in Java makes this great big tree of inheritance, and all the classes inherit from each other. And as an example, let's pick a random Java class and look at it. What class should we look at? How about random? Haha, that's kind of funny, because I said a random Java class. Okay. If you look at the API documentation for any class in Java, you'll notice the java.util.random class inherits from the java.lang.object class. Oh, that's a very shallow one. This is the object class. Okay, bad example. Let's find a bigger one. How about the Java JFrame class? Let's look at this one. Turns out JFrame extends frame, which extends window, which extends container, which extends component, which extends object. Why do you need to know that? Well, JFrame provides certain functionality beyond what a frame provides. And that provides some functionality beyond what a window provides, which provides some functionality beyond what a container provides, and so forth. So turns out Java really heavily uses the concept of inheritance because it's a powerful concept. And we actually used it in our game. Remember right here where we said game extends JFrame. So we just added to this hierarchy. So game extends JFrame, which extends frame, which extends window, which extends container, which extends component and object. And if you ever look at your game object in the debugger, has anybody done that yet? You'll find it has about 50 to 100 member variables, a lot more than these 4 that I just added. Why? They're all part of the JFrame class, or possibly one of these classes in the hierarchy. And this great big hierarchy basically means your classes can get really complex and do lots of fancy stuff without you having to write all the code. Okay. So back to how does polymorphism work? This is what a Mario looks like, because it has a Mario component, as well as a sprite component, as well as an object component. And the object component of every object, which is a funny way of saying it, Don't get them confused. If I say object with a capital O, I'm referring to the name of the class that is the root of all classes. If I say object with a lowercase o, I'm talking about an instance of a class, a little piece of memory that contains some member variables. How do you know which one I'm talking about when I speak out loud? Because you're smart and you can figure it out based on the context, right? Okay, there you go. Difference between object and object. And in my opinion, that was the worst name they could have possibly picked for the root class. They should have called it root or class. No, not class. They should have called it root class. Anyway, that confuses people. If on a test I ask about object, make sure you check whether it's a capital O or a lowercase o, because lowercase o, I'm talking about an object. Big O, I'm talking about a class. Got that? Okay. Inside of this object portion of every object, there is a pointer which points to the class object for that particular object. Does that make sense? That's why every object has this pointer that I'm talking about right here. Well, as it happens, every class object references something called a vtable. And a vtable has in it pointers to the actual places in memory where the methods are. So let's suppose this one is for update. That's a little big. Let's go down to 20. And this method might be for, what's another one? Draw yourself or something like that. And they'll point to where in memory is the actual code to execute that, to implement that function. Pretend that looks like code. Okay, so here's what happens when you call a method. When I say g.run right here, remember how g is going to become the this parameter? It's the very first parameter passed to that method. Well, what actually happens is it takes this object and it first looks up the vtable. So if this object happens to be of type Mario, it's going to go to the Mario's class object and get the Mario's vtable, and the Mario's vtable is going to point to the Mario's update method, and it's going to call the Mario's update method. If, however, I had used a tube to call the method, well, then it's going to follow from that tube object to the tube class, which will use the tube's vtable, which will find the tube's update method. And so it'll actually end up calling tube.update. And thus, basically, whatever object you use to call a method, that object is supplying the vtable, which tells it which methods to call. And thus, here's how I get to write my code. I'm going to come down here in my model, and where am I? Okay, I have this iterator here, and I'm going to iterate through all of my tubes, except they're not going to be tubes anymore. They're now going to be sprites. I'm going to say sprite s equals it.next. And then for right now, I'm just not going to worry about collision detection. I'll just get rid of that. But I'm going to call sprite.update. Some of the sprites in my list are going to be tubes. Some of the sprites in my list are going to be Marios. And right here is where polymorphism occurs. Because right here, if S happens to be a tube, then it's going to follow that link to the tube class, which will find the tube vtable, which we'll call the tube update method. And if S happens to be a Goomba, then it'll follow the Goomba to the Goomba class, the Goomba vtable, the Goomba update method. And thus this update, which update am I calling right here? The correct one, all of them. Yeah, exactly. And this is how coding kind of starts to become weird and fun and abstract. We get to write code now where I'm calling s.update, and I have to think to myself, what is S? Is it a tube? Is it a Goomba? I don't even know. All I know is it's a sprite. Tubes are sprites, Goombas are sprites, and just because I know it's a sprite, I know it must have an update method. Why does it have an update method? Because right here, I said all sprites must have an update method. And because of polymorphism, when I call object.update, it'll use the type of that object to determine which update method to call, and all of those things will get updated. And then I'm going to have to come back later and get collision detection working and figure out how to integrate that with the whole system. So we'll do that in just a minute. But right now, let's get this working where I can update whatever kind of sprite I have. Sound good? Okay. So I'm going to hit save and build, and it's going to find a whole bunch of compiler errors for me. And that'll tell me all the spots I have to fix. Model.java 127. I made an array list of tube, but right here it says it's an array list of sprite. See that? Fixed. Next one. Incompatible types. Sprite cannot be converted to a tube at model 163. Okay. See how tubes is actually a list of sprite? So I have to say sprite. And I can call it T, but you know, S feels better to me, so I'm going to say S. And now it's going to complain because sprite doesn't have an isInside method. And I'm going to have to, basically this one change is going to cause me to rewrite pretty much all of my code. And that's deliberate. So you're probably going to be a little grumpy at me for this, but here's the deal. Good code can be shuffled around and moved really easily. Bad code is a pain to move around and shuffle. And imagine this situation. You're working at a company and your boss says, okay, do this, and you spend 3 weeks doing that, and then your boss comes back at the end of 3 weeks and says, you know, I just had a new thought. Let's do this instead. Do you think that will ever happen? Yes. Oh, yeah. And if it's not your boss, it'll be you. You'll be coding along and you'll think, oh, wait a minute, I should have done it this way. And you will be changing your code over and over and over. It's been said code is kind of like water. When it's moving, it's good, it's clean. When it's stagnant, it gets rotten. That's kind of true. Code should move. You should be constantly shifting stuff around, rewriting stuff, making new connections, because when you do, the code stays clean. Somehow that oxygenation process gets the bugs out of your water. Yes?